Day 68, page 272, rotational kinematics, problem 67. We have a solid cylinder rolling down a ramp. In the past, we've had things like sliding down ramps without rotating, so we've transferred GPE directly into kinetic energy, sometimes with losses, sometimes without losses. But here, we have to pay attention to the rotational kinetic energy at the bottom of the ramp in addition to the translational kinetic energy. Also, it's important that it's not slipping. So there's some frictional heat that we're ignoring if there's some sliding and slipping. Anyway, we have GPE here at the top. That's the initial available mechanical energy. As it rolls down, the disk, when it gets to the bottom, will be moving linearly, translationally, with the kinetic energy at number 1, which is the typical type of problem we've done before where a block, say, slides down a ramp without rotating. But it's also rotating, so there's some energy in the rotation. We'll call that kinetic energy 2. So when it gets to the bottom of the ramp, it has these two types of kinetic energy, assuming no losses, no slipping, no friction. So in other words, the conservation of energy prevails. So the GPE at the top is equal to the kinetic energy translationally plus the kinetic energy rotationally when it gets to the bottom. So now it's just pure algebra. So mgh at the top, GPE equals 1/2 mv squared translational kinetic energy plus the rotational kinetic energy. And for a cylinder, the rotational inertia is 1/2 mr squared. So this here's the rotational moment of inertia, rotational inertia of the cylinder. Omega is V over R, as we see once again over here, the relationship between tangential velocity, linear velocity, and the rotational speed or velocity of a rotating object. So we plug this in for the V over R, and once again, simplify a little bit over here, we'll get 1/4 m, and the r's cancel. We're going to have r squared over r squared, so you just end up with a v squared. And you'll also notice that the m's will cancel. All three terms have an m, so I can cancel out the 3 m's there. And we're just doing this symbolically anyway. So there's a simplified picture of what's going on here. And then adding the 1/2 v squared, 1/4 v squared is 3/4 v squared, and then simplifying further, v equals 2 times the square root of that fraction. Make sure you make a large square root so the 3 is actually inside the square root symbol. GH over 3.